Oh, all right. Another night. Another bite. BYTE. Oh, computer joke. Let's do a sound check as always. Johnny 5 is alive. Johnny 5 alive. Okay, so I've been using the Johnny 5 Node.js module so I can control the Arduino and then control pins and read data from it as well. Well, I control it, but I haven't read any data from it. I finally got my fan module like working properly. So like that's been a pain, man. There was a lot of stuff that I had to like learn and put together. So let's walk through that. And I'll just gloss over this stuff. It'll be more like an obfuscate.min stream, if anything. So we'll just be going over the solution, what I did and what I had to go through. First, we'll start with actually calling it into the app itself. We do that. The index.js should not change much. There's some work that I still have to go back and do to that for MongoDB, if it's there or not there. But and that's a part of Node.js boilerplate, or the Node application boilerplate project that I have in my repo, which is github.com/treestarsystems. Links in the description if you guys ever want to check it out. Now, index.js calls app.js and runs all of the functions within it. So in app.js, I only want my fan control to be done by the primary instance. Since Node.js is a single-threaded application, you can actually run Node.js in cluster mode using the cluster module. I use that in PM2, but in PM2, I have a special PM2 config file where I say that one process is the primary process, and that's the process that handles cron jobs and fan control and other stuff where I don't want it to be replicated in any way, shape, or form. Armani, what's up, man? Appreciate you. Your mom just came by a little while ago on the way back home, so she's good. Good to see you, man. Appreciate you coming by. I know you're always in and out. Love you, dude. So in this case, the primary instance, that's where it runs, like, the one-time only code or the non-cluster mode code. I don't want things repeated or anything like that. I put it in something like this. So anything that answers web requests or anything like that, that's fine. That can be answered through the cluster module and proxy to any one of the single-threaded instances of the application. So this, I have to register, or I put in a fan regulator object. Before, it had things like speed in there and stuff like that, and I was trying to put that in, but I was having a lot of issues with the event emitter where it was actually overwriting some of my past the past parameters that I had. So like parameters that would pass into the event emitter, it would overwrite it. I later found out what was really doing it, which is the new keyword when initializing your fans. And it's pretty cool how Johnny 5 allows you to actually initialize multiple devices as well. So that's really cool. So I'm going to go over that. But this is how I get it started and have it run a part of the main process. There is fan control, regulator. Just noticed something. That's kind of weird. But yeah, so fan control and then the fan regulator in here. This is where I pass in my pins. I wanted it to be able so I can pass in pins and do whatever I need to, and be a little bit more flexible. So you don't have to like dig through the source code or anything like that, just to change what pins your Arduino has everything plugged into. So that's just a bit of ease there. So you can move things around, or if pins get destroyed on your Arduino, you can move it around. The next is under core. So most of the work was done in core. So let's go over temperature sensor. So, forgot I gotta zoom in. Sorry about that, guys. For those that do watch on the playback, always appreciate you. Yesterday we did go over the regular expressions that were used. to test to see if like I can filter out anything that does not have this pattern. Will be filtered out, creates a whole new array, and that's the array of our sensor IDs. One thing I did add in here is under read all sensors. So read sensor all, I added the average temperature function. So in this case, I'm averaging the temperatures from all sensors that are actually collected for sensor IDs that are collected, and I put that as a whole nother property in the object that is passed, which has all the sensor readings, the individual readings for all the sensors, and then of course the sensor readings, the individual sensor readings and all of their different conversions. So that's all done for you. And then then I have an average, which is an overview in a sense, and it takes all those sensors and does an average. And it uses a dot map. I found that online, which is really good. I thought it was pretty good, a really good solution. I did it myself. I was like, okay, how can I do this myself? And then I went on and did it. Then I went on and found something that did it in one line, which is like way better. So it's cool to see it, and it's like, oh, okay, I know what to do in the future. So this is how it looks. This is how it looks individually. So your payload is an array of JSON objects, and it has a sensor ID, sensor name, sensor ID, the reading, and then it has the raw reading, which is the milli degrees Celsius, and then Celsius, and going from there. And I put it in the order of KFC. So I was thinking about chicken when I was writing this. And then average temperature. I give you the average temperature for all of those different values. At first, I just did Fahrenheit. And then I thought about it and I was like, okay, it's good to do all of them. It doesn't take too much to get that done. It kind of sort of did. But I got it working, and the overall project is better for it. So readings by scale, I just have initialize an empty array instead of doing it later. It just makes it a lot easier and I think cleaner. But it does make it to where it's a little bit constrained, so it's not like as flexible. So that's not a big deal. You just got to add it up there. Down here, so for instance, the sensor IDs, I have all of the sensor IDs, and then it cycles through them or it iterates through them. And then it actually pushes all those to a new array, which is up here. And then that array gets taken and then ran through this average formula, or this average function here. And this uses reduce. So what's nice about this is reduce, what it'll do is it'll iterate over every array or every item in the array, and then apply your reduction function or your function to it. So in this case, I'm adding A plus B. So it does that for every point. So A, like, you know, the item at index 0 and 1. And then once it does that, goes on to the next one. The sum of the item in this case, because it's adding the 2, the sum of the previous sum plus the item at 2, you know, and then it just keeps on going through. And then you divide that by the length of R, which in this case is the reading that's passed in there. So once that's done, it adds it by scale. So average temperature readings, and then RBS. I'm just doing a for in loop here, and then gives me my average reading, starts to add that to it. So once that's averaged, and this RBS just stands for the reading by scale. So that means raw, K, F, and C. All right. Once we do that, so I'm just going over this really quick, but, you know, it's just, I've been at this and for a while, all day, and I was up until wee hours of the morning, even after the stream. Like, I was up until like 4 or 5 o'clock after that stream, and went to bed and woke up probably now again at 9 or something like that. So I'm like semi-tired, and I still have some other work that I got to do. But that's my fault, you know, like putting this, my personal project, over some work stuff. So yeah, I got to get to that. So all sensor readings, push all of those into, it's an asynchronous function. So push all of those into where it needs to go within the main readings object. And I got my test block here, and I keep those in there save the file, then I can test each one of those functions as needed. All right, so I mean, that's pretty much it for the temperature sensor, just adding the average function. Before, it was actually in the fan regulator JS, and then I moved it out because I thought it would be a lot better in the temperature sensor module because it handles temperature, and it's also a little bit cleaner, so it's kind of abstracted away, which I think is a lot better way of looking at, or a lot better representation or way of doing that, or a lot cleaner look to it. So fanregulator.js. Okay, so one thing I did is, like, I started using events. I have my own custom events. So I required all those. I'll probably switch this around a little bit. I usually like system modules to be first, and then all my custom modules to be second. In fact, let's go ahead and do that now. I'm just going to do that on the other screen real quick. Where is that? That is fan regulator. Regulators, roll out or mount up. Yes, that's all right. Good. I'll commit that later. Alrighty. So that's the fans. So on startup, since it releases control from the Arduino, then since it releases that control from the Arduino, the fans will kick on for a little while. It's not a bug, it's a feature. I kind of like it too, because then on initial startup of the system, it's kind of a test, so you can hear the fan. Also, it'll cool it down if anything, but it doesn't last that long, so we'll just call it a feature, but it's really not that serious. And if anything, I would like it to probably maybe be off, but I understand why it's not. And it's probably me nitpicking, if anything. Let's see here. So I don't want to miss any comments, if any, tonight. All right, so default scale, I made this available up here, just so it'll be easier to switch things around. Also, default temperature, just in case you can't read anything from the temperature sensors, I'm just going to have it default to 70. Actually, I'm going to have to default it to 80 because I have it turning on at 80 degrees Fahrenheit. So I made that change in the ranges, because at 70 degrees, it's probably about 71 degrees, 72 degrees here in the house, and it's pretty cool. Now 70 something degrees outside on a hot day is going to be a little bit different, of course, but I think it can handle it and it'll be okay. We'll see how everything works, and then that can be adjusted. One thing I would like to have is to where those adjustments can be done up here, and then you can actually make those temperature adjustments, and then they would go into effect down here in the conditionals. So I don't know what I'm going to do about that. I mean, might leave it. We'll see. Like, it's only in one place, and if you have to switch it from, you're from, whatever it is in Celsius versus Fahrenheit, then is what it is. This might be something that no one changes, and then it also kind of semi-refutes some of this stuff that it makes this kind of like futile. Like, what's the point of that? But just want to put it in there. These things I think are kind of nice to have. All right, so I made that change. Now that should say 80 on the next commit. Okay. All right, so here I have I set up a new event emitter, and this will also, I can actually assign event emitters and listeners. So in this case, I have I use the event emitter library, or the events module, I should say. And I assign that to adjust fan. And so the problem I was having is that I would set my interval. I would have, take that out of my ear. I would have set interval going. And with set interval, within the set interval, I would actually initialize my board, right? And I thought that was right. I was just like, all right, cool. I have my board code, and then I'm gonna initialize my board code. I'm gonna initialize my board code every time an interval is reached. So every second it would just do it, and it would be kind of fine. But then I would have like fans would go like it turned on and off, because I was having so many different event listeners, and they would actually build on top of one another and almost cause like a stack or a memory leak, if anything. So I would actually have your minimum, what's it called? Not your minimum, but your default value for event emitters is like 10. And mine would get up to like 11. It would go to 11 and then of course warn me. But you can actually set that in Node.js where you can actually change your max event emitters. That's a little bit further down here. And I think it's in this article or this portion of the article. So set max listeners. There we go. I had too many listeners on that board object and it would cause a possible memory leak. Ooh, piece of art here. This one's really cool. The Pale Horseman. So this is pretty cool. Or the Death on the Pale Horse. This one was freaking sick. I forgot to talk about this. I just jumped right into it. I've been so bad on the art thing and talking to you guys about that. Oh, wait. I guess we could do that instead of me like looking. I'm in a dungeon, I guess. But yeah, this is a really cool picture. I like this picture a lot. In fact, I think I'm gonna make it like my desktop or something. Man, this thing is freaking badass. Let's see what else this guy. Antonio J. Manzanito. It's like an apple zanito. Oh yeah, he's got some crazy stuff. I've seen his work before. I've seen this picture, Dragon Rider. Yeah, this guy's good stuff. This is definitely good stuff. Yeah. Oh, Akira. This is from the Akira movie. That's really good. All right, cool. I like that. So I was attaching too many listeners to my board object, right? Or my board event. So that on ready, I would actually have my interval, my loop in there, and that was causing problems. So I was like, okay, well, if that's the case, then I can't emit events in there. If anything, I should be able to actually have listeners in there. There's a couple other steps in between that. I won't go into all that because I semi-forgot, but you can actually see some of the changes that I've updated or uploaded to the repo where I was futzing around with it. You might see some big jumps though. So board.onReady. So once the board is ready, then I want to attach the change fan speed listener to the adjust fan event emitter or the event. Yeah, event emitter like that I actually that I initialized earlier. And in this case, it was formerly logging all this stuff, but I took that out now since I think this is pretty much done and out of testing. It's ready for release and ready for me to move on to the next thing. So I've spent like a long time on this, like almost like a couple days to a week, trying to get this like right. And then also learning while I was doing it too. And that was like a big thing because I just didn't know any of this. So there's some things that I found a really good way of learning and seeing recipes is going to the GitHub for Johnny 5. Here we go. So going to the GitHub for Johnny 5, there are a lot of different recipes. So under docs, there's the LED array. So what I was doing was I was actually providing my own array of LEDs, but then I was looping through it with like a for each loop and, for each loop for on the actual object itself. And then with that, I would run all my different code. Like, in some cases I had the board.on ready state event in that, and I had it for each LED and all this other stuff. And I didn't know there's the keyword or the function. There's LED singular, and then LEDs. So if you add just add an S to it, now you can actually provide it with an array of LEDs. Now this caused me a problem here because every time I emit events to it with this new LEDs, and I actually had to move this out of the set interval or out of the main function that was ran through my set interval, it would actually overwrite and wipe out the variable that I passed. So unless I hard coded it and say like, so my fan speed would be okay because I would actually give that a number and I would pass that to my pass that within as a parameter in my emit statement for my events. So I would emit this and then say, what the actual event is. So in that case, it was change fan speed. And then I would have an array of pins and then the actual number, right? And I would hard code this. This would be okay because in this case, I'm doing this every step. So this is, default, it'll be 170 in terms of brightness or fan speed. And then it would go all the way up to, it had three levels, and then it would go up to, or 4 levels really. So off, entry level, you know, the first level, second level, and third, right? And the highest is 255. Can't go any higher than that. I think it actually shuts the thing off. So, so I would actually, and this is for brightness, so you can change the LED's brightness. The same thing with PWM fans. You can use this brightness on it, and it would actually speed the fan up or, you know, slow it down. I haven't tried like the fade in and out, and I don't think I will. It's just I don't think it's necessary. And sometimes the time in between when all these fan checks are done is kind of short. I think I upped it to 30 seconds now. Yeah, like I think I probably upped this to 30 seconds now. Let me see. No, it's still at 10 seconds. Yeah, I left it at, I wanted to up it at 30 seconds, and I thought that would be too long because I have to be efficient with the battery usage. So I put it down to 30 seconds. All right. So, so yeah, LEDs, I could pass an array of LEDs. What would happen, even if I made the variable that I was passing a const, it would still overwrite it. It would still actually override it and not give any error whatsoever. And that was like, that threw me for a freaking loop. I thought there was an issue with the dot emit and passing multiple variables. And I even found articles to semi-prove that. But what actually happened or was happening, and I was like, yo, wonder if it's just this doing it. And I tested it. I did a console log of the variable before this was called and a console log after the fact. And that gave me a problem. Now that I look at this, it says const here. Maybe that would have solved my problems. Saved me some headaches. I don't know. I might go back and test that. Yeah, I might go back and test that. We'll see. Because sometimes I'm just like a masochist for pain there. All right, so here. So I would, in this case, I have dot on change fan speed and then give me the output. This is for testing. And I still have that line in there. I just took out this here for pins because it would overwrite it and make it 0 or 0 out my array. And then fans, I would do 5, which is what I have the Johnny 5 module assigned to, and then P for pins. So that's pretty much, yeah, that's changed a little bit. What in the world? So, oh, okay, hold on. Let's see here. Weird. Give me a sec. Let me just push these changes here. Get add dash P. Yes. Yes. Git commit J. And regulator module ready for release. All right, so git push. I'm your pusher. All right, cool. So great. So ready for release here, and let's go. No, hold on. Let's go back to that file. Be lazy. So what happens when you're lazy? All right, cool. So that's changed to 80. So this object that I was passing, which is in the app.js file, that kept on getting overwritten. All right, cool. All right. Change fan speed, brightness, that's good. And then dot on off. So I added this new event listener. So I just wanted it to turn it off because what I was noticing is if I called this fan speed and even if the temperature was set to 0, because I would use a random number generator to simulate temperatures. And you guys saw that yesterday, but I would use that random number generator to simulate temperatures, and it would, even at 0, it still wouldn't shut it off. So I made a new event listener, for off, and it just turns the fans off. And I don't have to do anything like turn it back on or anything like that. Once I actually say brightness or hit it with brightness, which is here, it will automatically spin up to that point. Oh, excuse me. And then emergency shutdown. So when this event is emitted, that means the temperature is way too hot. I have it currently set for anything over 110 degrees Fahrenheit. And once it gets past that, then it's going to do the emergency shutdown, which would be something like, shut the whole system down or something like that. But at that point, it clears the interval and then makes some other changes as well. So then it doesn't run anymore, and it shouldn't do any more checks, and it should just shut the entire lawnmower down at that point. So there's more stuff that has to be done there. And I will be coming back to this and adding that emergency shutdown and whatever the tasks are going to be for something like that. We'll see. All right, so set interval to generate current temp. Okay. Enclosure's temp. So in this case, I set the temperature, or I defined the temperature, and I gave it the default temperature. And then now I have an asynchronous function, so emit temperature. And this emit temperature gets called during the set interval. Now, as you can see, Lionel, what's up, brother? I hope everything's good. I mentioned you in BGS's latest comment about the about BTC's retracement. I said, man, hey, man, that's good. Buy more. I'm ready for it. So I hope everything's good, brother. All right, so here, here I have my temperature readings, and that takes temperature sensor dot, and then the reading for reading all the sensors. And then if there's any failure or anything like that, then error reading temperature, defaulting temp to whatever the temp is, which is going to be 170. And then it's going to set the fan speed to 170. Yo, family. Okay, yeah, man. And Mike V, man, what's up, bro? I hope everything's good, bro. I haven't talked to you so damn long, man. I haven't been on a stream with you. I haven't been on a stream with anybody, really, but I haven't been on a stream with you in a minute. It'd be kind of cool to chop it up, man. I've been making, connections with other people. Like Dan Tuku was on the stream the other day, and that was a really good stream. But yeah, if you want to get on the stream, bro, and just talk tech and some of the other things that are out there, and also the future of technology, I might actually reach out to you on that. So thanks for the inspiration. The future of technology and automation and some of the other things that you guys talk about on the Black Brain Trust. Definitely want to hear more from you, bro. All right, so here I call the if there's any failure or anything like that, because we're using our standard return object syntax or format for our functions. So we have a predefined template for our return functions. It always our return object. It always returns a status, a message, and a payload. And that payload could be anything. It could be a single data structure like an array or another object or an array of objects or anything. So you just got to know. One of these days, man, Jamaica Automation District is looking good now. What? Jamaica? That'll be cool, bro. And me being Jamaican, I could be like an ambassador. That'll be cool, bro. We could talk about that. I'm gonna send you an email after this, actually, and let's put that together for sure. Maybe make it a recurrent thing, man. You're more than welcome to do that over here. I'm totally for it, bro. Damn, Jamaica, my people. That'd be cool too. Like I can make that connection since I'm like trying to do this as well, and I am Jamaican, so that'd be cool. Now you got me thinking about oxtails. I gotta cook some more of that. My mom found this great oxtail meat, and oh my god, I'm talking like the oxtails are like literally this freaking big, man. And I'm not even over exaggerating. They are literally this fucking big. Like the oxtails are this big. Even after you cook them, they're probably like a little bit smaller. And I'm talking like sweet meat. Golly, that meat is so damn good. Pause. So yeah, man. All right, cool. So yeah, okay, cool. Yeah, we'll get together, Mike, for sure. So here, at the temperature reading, if I can't gain temperature sensor readings or anything like that, I don't really care so much about the failure. It just failed, right? And it'll give me an error here, so it'll give me the payload. But then we're just going to emit fan speed at 170, and that's all we're doing. All right. So that could be like it had a file system lock or something like that, and it couldn't get that information for me. So in this case, retrieve average temperature. This is weird. So like I have to be doing something wrong. I shouldn't have to have two loops for here. Shouldn't have two for loops here. And I don't think I should. Like I should be able to get the temperature reading or get the temperature readings and then cycle through those. But then I have to actually, with the temperature sensor readings, the way they're situated is that it is going to be the payload, which is an array of objects. And in one of the objects, and if anything, I should just not make it an array, I guess, and just make it an object to where I can address all of this. And that would be easier. Okay, yeah, that'd probably be easier. But I have an array of objects, and two of those objects, in this case, because I only have two sensors, two of those objects are actual sensors or objects that have, you know, the sensor as the key, the sensor ID as the main key, and then has a readings sub property, and that readings property has, excuse me, another JSON object that has the raw, the Kelvin, the Fahrenheit, and the Celsius readings or calculations. So, I mean, I guess I could have just assigned that and just not needed that, but I have two for loops because I have to loop through the actual payload for all the temperature sensor readings. So those are JSON objects. Then I have a for in loop, so I can iterate through or loop through the JSON object itself. And then once I loop through that JSON object, then I say, okay, if AT, which is the element in this case, or the current element that it's on, if it equals average temperature in terms of the actual key name, then temp equals all of this here. And then I put default scale, because this is where I'm looking for that default scale, whether it's Celsius or Fahrenheit or something like that. All right, cool. And then after this is then it's the simple stuff, right? Like, you know, the logic. So if below 80 degrees, then turn the fan, emit the off. If 80 to 90, emit, change fan speed, and then change the fan speed to 170, which is like the minimum for high-speed fans. I noticed for fans that are like 3K above, like I have this Noctua fan, which I ordered in error. This is a 140 millimeter fan, and I need a 120 millimeter fan. But I mean, I'll probably use this for something. But this sucker goes pretty fast. And I'll probably get more of these because I got some 5K RPM fans, and those suckers suck a lot of power. So I'll probably be going a little bit lower on my fan spec just so I can actually reserve battery power. Even though with like a full charge, this thing does pretty well, I must say. The battery, that is. And I've kind of drained it because I was doing so much testing since last night. And that's not really good for lead acid batteries. So I'm definitely, after all this, that battery probably should not be put into production, or even like once I actually get a lawnmower, like, it's not going to work out. All right. And then one thing I was having a problem with was the conditional. So if temperature is less than 80 degrees, right? Now I had here, if it's less than 80 degrees, meaning all the way up to 79.9 repeating, it should be good as long as it's not 80, right? Like if it's less than 80, so that should be good. But then I was having a problem with if I had equal to or greater than or equal to 80, then it would be a problem. Like I was getting stuff where it wouldn't turn off properly. So now that I'm kind of thinking about it, that might not have been the issue, because right now what this means is that if it hits 80, then it's going to be a problem. Yeah, if it hits 80, it's going to be a problem here. Like it just, I don't know if it'll not know what to do. It doesn't have anything for it. So maybe it just doesn't change anything, which would be okay. So that's a bit of a gray area. And then of course it'll catch it on the next go round. But with the way this temperature sensor works, or the readings, they actually don't come off as actual rounded numbers. Like they don't round up or down. They're like the exact milli degrees, like Fahrenheit even, or Fahrenheit with probably a couple decimal places, like no more than a few decimal places, like 6 or 7 decimal places or something like that, from what I remember. But changed that and that fixed the issue, and then went from there. I mean, these are just regular condition. These are just conditionals, and I just do them in the form of guard statements, and then I just describe everything. I'm actually getting a lot better documentation as I'm going through all this stuff, so that's better. And then we finally have the what's it called, the star of the show, which was causing a lot of problems. A lot of the code that you see above was all in here. I made it a little bit cleaner, where I just calculate average temp equals set interval. I made a lot cleaner here by just having it here and just having a function and abstracting that away a little bit. I mean, you can kind of call it clean. I mean, all the mess is up here, so what's it called? Look at it however you may, but I think it's clean. I just noticed something here. I'm going to get rid of that extra space. I think it's clean. All right, cool. Some things like I'm like space in between certain pieces I like to have, but then something like at the end, the closing block, I get rid of that space. So, and then catch, and then that's it. I mean, that's pretty much it. So in terms of what I did, I mean, that was that was a quick overview, but oh my God, there was just like so much back and forth, so much testing. But I do feel really fulfilled with this code and like how it's actually running. I actually took my little candle lighter here and just held it up to the temperature sensor and waited for it. It took a while, man. It took like a minute, like two minutes or so. So that's like 2 minutes every 10 seconds. That's like 12 cycles or so. Probably even longer than, probably like 2 minutes. And this thing was almost running out of, like, I might not have any oil in this thing anymore, or, oh no, I got a lot of fluid in this sucker. But it actually went down in terms of like, the flame. I was just like, oh God, I'm running out. But I held it to the temperature sensor long enough and it kicked on. And I was very impressed with that. So that means if the ambient or outdoor temperature or the temperature within the enclosure gets to a high enough degree centigrade or high enough temperature, it will kick on and try and protect it. So I don't know if I'll have temperature sensors outside of the unit or what. We'll see. It may not be totally necessary because I only care about what's in the actual unit itself. But it might be good to actually have something like this where I have this type of code running for maybe like, the battery enclosure, however I choose to separate things. So, yeah. But, yeah, I got that going. And the last thing I'll talk about here is just kind of like I'm looking at, how everything is situated in this, and I want to start mounting everything via, this is like 2, right. Does it look bad? It doesn't matter. So I want to start mounting everything via DIN rails. This is something that I got from electronic salons. I've talked about their products before, and they have a lot of like Raspberry Pi DIN mounting modules with breakout boards. I use it for the Arduino. You've seen it in the project. So the DIN modules allow me to hang it, and it's like a standard in terms of like connectors and things like that, and it's good for conduit boxes, electrical stuff, and stuff like that. This is the relay board. Ooh, let's do this. This is the relay board. I ordered the wrong one, so I need something that's going to be, I think, 5 volt, and I got 12 volt or something like that, or I needed 12 volt and I got 5 volt. So I'm probably not going to use this. Yeah. Oh, yeah. Electronic Salon. I'm probably not going to use this. Oh, it's also, also known as CZH-labs.com. So probably like Shenzhen or something like that. So I haven't tested this product, haven't used it at all. There's also not really any space for it, but I'll probably have to make space sooner or later, add some more DIN modules and stuff. So yeah, like I'll probably be using this. But until then, you can actually order this from Electronic Salon. You can actually order this like piece, and These, of course, are the DIN mounting brackets that come on them. You know, so that circuit, this board here, I can actually mount it as a DIN. You know, put it all back together, but mount it as a DIN module. So, but what I'm going to do is I ordered a piece of plexiglass. So the plexiglass that I ordered was probably 1.5, I think it's 1.5 millimeters thick, or the size of a penny. I think it's like 1/16 of an inch. And I ordered that so that I can actually start using, and this is the plexiglass I got from my local Lowe's. I like this. It's a little bit sturdier, right? If you guys have looked at the Grow Box project, I used plexiglass. It was a lot easier to cut. I used a piece of paper, then cut the plexiglass to that shape, and then mounted it in the box. That way I could actually take it out of the box and do whatever I need to, put it back in the box without doing too much damage to the box, or mounting directly to the box. And then this is really nice to actually have a piece of plexiglass like this, because it's sturdier, a little bit flexible, and then I can actually have all my all the placement of all of my my items. I can have all the placement of it on this. So like I could have these like little standoffs that you would see for motherboards, the motherboard standoffs. I can actually screw them in, attach it to this, and then I can actually have the unit sitting on top of it, or Raspberry Pi or what have you, and it actually turns out really nicely. In fact, let's just look at that real quick. Sorry guys, I'm not so enthusiastic, but it's just a lot. Oh, so yeah, we'll see it here. All right, so this is a piece of plexiglass here, and this is a very rough cut, but you can see how I have the motherboard standoffs, the relays, and everything else like that. And then all of that mounts into the box pretty nicely, so I can actually remove it from the box without puncturing any holes in the box or anything like that. So it's a nice cleaner setup, and I can remove that if necessary. And then it maintains as best as possible. I mean, I do have this big ass hole here and this fan hole here for exhaust, but it maintains a better, it maintains a little bit more water resistance, even with some of the things that I have to do to the box itself. So yeah, this is really nice, and this is it without like all the stuff in there. But you can see how I have all that, and this is like 2019, man, crazy. Look at that, it's like my old table mat in the house. Look, it's a 1-wire sensor there. So yeah, that's really nice. And let's also bring this up in another window. Made an order today. This one was actually pretty good. And this. And this. All right, cool. So first, we'll go over this. What I did here is I just got the piece of acrylic, and I used it based off a measurement of another posting. They were nice enough to like pretty much show you like, hey, listen, if you have a penny and you can fit it in there, that's about 1/16 or 1.5 millimeters. So that was really nice. 1.5 millimeters will fit in this and then actually have some play to it. So in terms of my cutting, it's going to have to be pretty exact to where I can actually put this on the side of it and then, keep everything in place and keep it tight, because you can actually have a piece of the plexiglass go into this, the edge, the bookend, if you will, here. So that'll be nice. And then it should be a pretty tight, it shouldn't move too much, especially with everything moving around. It should be okay. So the bigger the piece, then I can actually have it like fit in there real nice and snug. So that'd be cool. And I have to get like really exact measurements. So I will be using millimeters for that. On top of that, so what I found out about PWM is that I can actually have multiple devices hooked to one PWM pin. So in this case, in my Arduino, I actually have both of my both of the PWM signal cables going into the same port on the Arduino. So with that, I can actually control both fans, and that actually saved me from having to control multiple ports. But I still used in Johnny 5 the .LEDs method. from the Johnny 5 module. So instead of singular LED method, and I could still use the singular LED method. Like it's still fine. I can use it. Like, you know, I could just pass it just one LED and it'll be a lot easier for some of the stuff and save me a little bit of headache. But this is pretty nice because now, for instance, what if I have the LED for the battery? You know, I can like control different ones at the same time with the same type of conditionals or not conditionals, but the same type of logic or conditionals logic. Yeah, same thing. So same type of logic. So I got one of these, and this should be a lot cleaner. Again, this is why I brought up the whole plexiglass, because I can mount it to something like this depending on the size, or get multiple of these and put it in that larger box that I got from Vevor, which really good box, and I should have some really good fun with that. That's going to be clean. That's going to be clean, indeed. I also got the wireless stuff, but I didn't get to work on it. I need power for that, and I just wanted to work on the fan regulator code and get that right. So I'm really glad I got that going. So with this here, excuse me, I can mount that, mount it nicely, have this, and then looks like it's 15 inches, so it'll be a lot. But the actual connections going to it is gonna, you know, that's gonna be a little bit harder to do. So I'll have that, and I can have this as the breakout board. In this case, it shows you in a case fan or a computer case. So you can have all the different fans and everything, and then that should be controlled by the same PWM and also power as well. So that should actually cut down on cabling. It's a pretty much a multiplier or a fan out, if you will, which is really nice. And a 15-inch cable, so that's going to be good too. I'm really excited about how this is going to make things cleaner, especially for revision 2 of this whole thing. I mean, this toolbox, I mean, it's been great as a prototyping platform in terms of space and, you know, moving things around and, you know, seeing how it's not adequate, but then also I can destroy it because it's $70 versus 200 something bucks, which I paid for that other case, you know, so our Enclosure. So I'm happy with the Enclosure. I was going to return it, but I'm also very happy with the toolbox as well as the prototype for this whole project. Yeah, so I noticed this here. So like I can plug all my power and everything into it. And what I also did is got some oh, I didn't get the connectors. I did not get those connectors because I didn't think I needed them. I didn't want to make connectors for this, but I might go back and do that. I might go back and pay for that. I got to think about that because it's like it's hard to sometimes think about this stuff when you don't have the product in front of you, you know, like you start to see the possibilities when you start having the Arduino in front of you. You start to think, okay, well, if I have PWM signal, can I put this all on the same thing? And then you try it and it's like, oh yeah, that does work because I mean, you could Google it, but then there's no concrete way of saying, oh, okay, hey, put the same thing, like, you know, connect multiple things to the same PWM port. Port 2 or something like that. And then a lot of the how-to say go to port 9, where it's just like, why do I go to port 9 on a Arduino when I have all these other ports? So do the other ports support what I want? So you got to like work with it. And I have the Arduino Mega, and it's like, okay, like, you know, I have more PWM ports that I can actually use, so why not use them? You know, because coming from like the quote unquote Raspberry Pi world of things, certain pin, like since it doesn't have as many pins, and also some of the pins have different functionalities like I2C, different IO pins, and power pins and things like that. Most pins have, I think it's like SPA, SPI pins or SPD pins. So most pins actually have a purpose. And, you know, you don't have a lot of pins to work with in some cases, and you're going to have to like twist wires together to put it in. So unless you get the product, man, and start messing around with it, you don't really get to see these things. All right, last thing. Yeah, so I just got some extension cables. Yogi Fish. What's up, bro? This is the first time. I don't think I've ever seen you on the channel or anything like that, man. I really appreciate you, bro. I appreciate you coming through, man. Just giving me those emojis, that motivation for me to keep talking. I appreciate you, man. Thank you so much. I probably got shared or something like that, so that's cool. If somebody shared me, thank you a lot, man. Probably like Mike V or Lionel or something like that. So thank you guys. The shares are great, you know. It's just like this is the quote unquote boring content, but this is also the six-figure content, if you will, right? Like I talk about, or I don't talk about investment. I talk about like mostly mindset and stuff nowadays, and not so much on investment anymore, but because it's just almost not needed. Oh, I watch your shows. Never been in your live. Oh, okay, cool, man. Hey, welcome, bro. Welcome. Yeah, my lives are like super sporadic and all over the place. But I decided to do this, man, because I was really happy about the fan regulator and getting that working. So yeah, I appreciate you, bro. Thank you for actually just saying what's up, bro. Because there's some people that they don't want to do it. All right, peace to you and Young Grizzly in the chat. Gold Professor, what's up, brother? I've seen you in the space in many different ways in many different places, man. So appreciate you guys. Yeah, definitely. It's definitely great to get all the things working. So here, these are some extension cables so that I can get from the fans and then get to the PW, get to the main connector. Not main connector, but get to the hub, if you will. Yeah, fan hub. So get to the fan hub. I'll actually use these connectors, and these connectors, it's a 10 pack, so I can have like 5 long cables if I wanted to, or mix and match as needed. But I think this is I think these cables are almost 11.8 inches, so they're almost a foot long, and that should be way more than enough to get to the hub. So that'll be centrally located, and I'll be using this eventually. I'll be using this to actually mount the fan hub and to mount the actual sensor adapter as well. So all that'll be here, and maybe even a breadboard to it as well, just so I can hook up multiple sensors, depending on how I hook up my one-wire sensors. Because I want my one-wire sensors to be able to actually have a nice sturdy connection, because a lot of stuff falls out. But also I have to think about things like, adding more sensors later on. Do I want to just twist the cable, or it would be better maybe to strip the sheathing off the cable and then solder the cables as well, solder them together? And do I want to solder when I add another one? So once I get into quote unquote production, if it gets to be a bigger project, then I might get into soldering, and by that time I should know how many sensors I need. So I might not need a whole bunch of sensors or anything else like that, So these are things I think about, while you're going through and prototyping a lot of this stuff. And it's fun, it gets the noggin jogging, if you will. So yeah, I had this, I got these here, and the only thing that I need from this is that it's for extension, but the only thing I'm gonna need coming from this is going to the actual from the hub. I have to think about what's going from the hub to the power and the Arduino itself. So I'm gonna have to make a custom cable. I can either use a 4-wire conductor cable or a 3-wire conductor cable, which I do have. But I don't want to also limit myself. But for prototyping, it might be okay. As you guys saw in the last video, I had strands of cable all over the place. So that's one thing. What's cool is that I actually have my fan regulator running right now, and it's running every 10 seconds, but fans aren't turning on because it hasn't reached the threshold. That's really cool, man. It's really cool. That's really cool. I like that. All right, so let me show you what I should be getting, or I'm probably going to order after the stream here. I need to wash some clothes and take a shower and do some other stuff, but give me a sec. Let me look at my browsing history. Duplicate that. Go back one. Can I go back one? Oh. I done messed up. That's that. Need the female and male side. So that's the female side. All right, cool. All right, so here, are these new designed cables? No, these are your usual case fan for your computer case fan cables. They come in a wide variety, usually a 3-pin for your lower grade fans, if you will, and then a 4-pin, which allows for different fan control and regulation and stuff like that. So you usually have that little fan controller in the front of your case or somewhere on it, or the software. Even now, it's like mostly software, and then you would just turn a dial and then it would change the speed of the fan. Now I'm learning this. That's a PWM controller, pulse width modulation, that actually does that controlling of that. So you would actually, I think I forgot what the yellow pin. There's 4 pins. There's the black, which is the negative terminal, red, which is the positive terminal, yellow, which is the TAC, and then blue, which is the PWM. And that's like usually the color standard for it. And you'll see that even on like this fan here, you can see those cables there, and then it has the connector here. Yeah, well, it's not that great, but this connector would go into the motherboard, the male pins on the motherboard itself, plug into that, and then through your motherboard control software, what have you, or even a physical control software, you can actually control that and then change even the temperature as needed. So this is a well-known standard, or a well-established standard, and I've seen it. I never knew what it was really, but I've always seen, your 3-pin and 4-pin, and you can actually, go down from 3 to 4 and stuff like that. So yeah. But these aren't new cables, but I can make my own cables in a sense with these kits here. So I'm going to have to make my own connector coming from the hub itself, and then going to power and the Arduino. So yeah, that'll be pretty cool. So I have to order this set. I took it off because I was like, oh, I don't need it. I don't want to make cables, blah, blah, blah. But then I didn't think about like the last cable that I have, because the other cable I'm going to have is going to split off. So I may not need these now that I think about it, because I have, and thank you guys for allowing me to, you guys are my rubber ducky today. Definitely listen to the coder video about rubber ducky, and it's actually really good. Hold on. Coder. And I've put this video in the chat before, but it's great because you have somebody you talk to, and even though I'm like kind of tired and want to just like veg out right now, and I do have some other stuff I gotta do, I like doing this too, because then one, communicate with other people, chat and stuff like that, pour knowledge into people and stuff like that, answer questions, ask questions of myself and other people, and also it's good because then now I'm talking through this stuff in my like that's coming out of my head, and then it's like you're putting it up against someone else, and as you're talking through it, you're thinking about new things. So that rubber ducky thing is great. Okay, I see that I have some work. I have to do some work, meaning catch some replays, catch your lives, and ask questions like, okay, what are we talking about again, teacher, sir? So go professor, talking from one, I'm an adjunct professor. You're tenured. So essentially what I'm talking about is the GAMR, or the Grizzly Autonomous Mowing Robot. That was name given to this project by Aquatechy, but essentially I'm trying to make a self-driving robot. And I've gone through a little bit of work with it and building out a prototype, the foundational stuff. There will be like, you know, solar battery controllers. It'll have a solar element to it to control it while it moves around. And it'll also, of course, it'll be gas powered, but then just to run the electronics, you know, that'll be a 12 volt, 35 amp battery, and the possibility of extending that to even more if I need to, so I can have more capacity or runtime. So things like that, man, it's just like, we're just going over that and talking about it as I step through this process. I don't know how far I will get this project and how long it will take to get done. This could be a multi-year process for me. There are other people that are doing this and have done it using just Arduino. I want to do a little bit more and go after a little bit bigger clientele if I can actually make it into a product. And but there's a lot. If you look at autonomous mowers, autonomous zero-turn mowers, things like that, there's a lot of projects out there, and they're doing great things, like even image recognition. So if somebody's in object avoidance, image recognition, and also obstacle avoidance, image recognition for people avoidance, and also things like cutting the perimeter of the grass, and then it auto maps all the waypoints for the section that you're trying to cut. There's like a lot of cool stuff out there. And then even eventually having it to where it's like, okay, I can hook up a RC motor to this and then start controlling, different servos and stuff as well. Instead of it being autonomous, I can switch to RC mode and control it myself, which will be really nice for those tough spots and stuff like that. So I want to turn this into a product where literally you go out and you don't mow lawns anymore, Yeah. Oh, I'll get to that one, Yogi. There's one guy that actually, a handicapped guy that actually is doing this, but he does it with a smaller lawnmower. But getting to the point where, you pull up to a lawn and literally you RC control it, and you never get out the truck. You RC control the mower, turn it on and everything. Maybe all you got to do is go out there and let the bed down or something like that. But you can RC control everything and then cut your customer's grass, put everything back in, or you can have it run and then you do all the edging. And then this, you don't have, a second person anymore. Now you just have a lawnmower that's totally autonomous, which is freaking sick. It's been a project that's been out for a long, long time, and there's a lot of other things that I need to get to with it as well. Yeah, I went to kind of far on that one. Yogi Fish said, that's a great idea. Handicapped people need those tools, most definitely. So there's one guy that is doing it already. What's it called? Autonomous zero turn. And if you just search autonomous zero turn, there's a lot of projects that are doing it. Yeah, farm harvesting can do it too. Like I've seen big tractors with it as well. But if I can do it and do it open source, oh, even better, bro. That'd be sick. I forgot the guy with the wheelchair, man. There's like, if you look at that search, oh, you're gonna see a chick on one of them. But if you look at that search, man, there's so much that is that's just out there in terms of people doing this with RC remotes and stuff like that, and auto stopping. So essentially, you don't have to do anything else anymore. It's definitely a rabbit hole that you can get down, and or you can go down and do a lot with. Man, I can't find the guy's video. The guy's handicapped, and he actually did his own auto mower project, and he uses just a regular household mower. Like the regular push mowers that you have. In fact, let me just get a video of something that's like that. And this one's even better. Oh no, this is a zero turn, but this is this one's even better. All right, cool. Gold professional. Let me catch up. Okay, so we were speaking about robotics. My good sir, this is a field that I'm very novice in, Yeah, I like what you're doing. I have been to robotics shows, but to hear it spoke about on this level is different. Yeah, man, I appreciate it, man. I don't know what GP means. It's like good something. I forgot what that means. I apologize, bro. Don't know the lingo on that one. I know, you got like GS, which is like good shit. Or GP, I know, it's like good people. Yeah, man. This is going to be something that's like revolutionary. And if you can do something like this, man, and I want to make it open source, or it is open, the code is totally available right now. You could download it. You've seen the multiple videos, and hopefully I can get to a build video where I actually build one of these from scratch and put it all together and assemble it so people can build their own thing. I don't really care about like, you know, having the software to myself because I can always sell support contracts. And also to sell the software is a little bit hard since it's Gold Professor. Bro, okay, cool. Gold Professor. I apologize. All right, cool. So yeah, putting this out there into the ether is great, you know, and I think it'll grow a lot faster. Farm harvesting needs this too, for sure, especially black farm harvesters as well. There's the Growbox project, which I got to get back into. Like all these projects tie into one another because I've been doing this for a while. But with this Growbox project, this was the environmental. This unit here that you see was the environmental control unit for, and I still have it. It's in my shed over there now, in my like workshop. And I brought it out just so I can look at it and do some get some comparisons off of it. But this was the environmental control system unit for container farms, and this would actually control like, you know, temperatures, fans, and other things like that as well. Power outlets and stuff like that for turning on lights on and off, and kind of just making your grow it's the Growbox project, but making it to where you can actually grow goods and then deliver them fresh to, you know, your restaurant in the area or what have you. Yeah. All right, cool. Got through everything. Sometimes, you know, I go deep with it, you know, sometimes, or like I really get into it. But yeah, the Growbox project is something that I really want to get back into. One of the things was this smart bucket here. This actually had these sensors. So, you know, if the water filled up, it was boom, and then it would hit that sensor and then tell you if it's like, you know, how full it is, or if it goes down, you would see how empty it is or what have you. And then it actually had a float sensor at the top, and that float sensor would tell you if it's full or not. And then that would be like, that float sensor would cut off the pump that was filling this bucket here. So I still got that bucket and still want to work on these projects, man, and like really get at it. So maybe, you know, maybe cryptocurrencies will like put me out of a job or something like that, to where I can actually do these things and save up and, you know, maybe work on this for like a full year or something like that. All right. So my father was understood technology. Oh, my father was one who understood technology at a time where it was very quiet. He was a tech junkie before the term became a real title. Yeah, man. Like, and my dad, he's into business, like just personal story. My dad's into business, and I've never seen that guy actually work a job. You know, like he's always had his own business as far as I could remember. So it's cool, like get those like influences from like, you know, fathers and father figures as well. Like you can see, like earlier, my nephew came into the chat too, which is cool. All right, so yeah, so one of the things I'll do is I'll probably make one of these cables here. But what I'll probably do to start off is I have one of these connector cables that has like a female side to it. And what I'll probably do is just go ahead and rip that off and then strip the wires. Now that I'm like looking at it here. Yeah, so yeah, I have the male side to it, and then I can rip that off and then have that break out to wherever I need it to. And I'll do that for now. And later on, I'll go ahead and buy these connectors here. So that's cool. Yes, sir. Yeah, man. So, all right, cool. I think that's it for tonight, guys. I might like take a little nap and then wake back up and get some other work done before tomorrow. There's some tickets that I got to handle. But that's pretty much it, man. As always, guys, thanks for listening. This is one of the shorter streams. Oh, shoot. Well, short for me, I guess. It's an hour. So this is one of the shorter streams, just going over some code review of some stuff I did. Sometimes I just code, man, and like, you know, I don't want to like talk to other people about it, and also don't want it to be a boring stream, and I want to interact with you guys. So it's not you just watching me code or something like that. So I'll code like little small things, and you guys will see me go through it and look at and talk through the process. But yeah, man. Hey, man, Yogi Fish, man, I'm glad to catch you too, man. We're glad you called me, and I'm glad we can interact. And, you know, always come back for these things, man, or even on the playbacks. Guys, you know, you can ask me questions in the comment section, right? You know, however you feel. You can reach out to me via emails. I was talking to a brother, Moody Bears, a while back, and kind of lost contact with him, or I haven't heard anything from him. But, you know, like I'm open, you know, to help you guys out any way, shape, or form that I can when I have time to. So let me know however I can actually help you all and any questions that you all have. Go Professor. Yeah, brother. You have a good night. Glad to be rocking with you, sir. Go. Hey, man. Appreciate you too, bro. So Yogi Fish, Go Professor, Lionel. Who else? Armani. Thank you for joining. Ice Mani. Mike V. I'm gonna reach out to you right after this stream. Thank you guys so much for joining the stream, and I appreciate you always. Sorry, I'm not too enthusiastic. I'm just tired. All right, guys. Peace. Have a nice one.